Hello friends. Today I have some kind of puzzle game for you. Recently I had an old programming book in my hands, and in one chapter recursive algorithms were explained, and they used the problem of the Towers of Hanoi as an example to illustrate it. And I thought, yeah, that would be really nice to have this in our samples, the Towers of Hanoi, solved with this Famos script and visualized in a simulation. Okay, the simulation and the script are now part of the sample package, the Pick&Place sample package that you can download on our webpage, so you can play around with this sample on your own. Let me explain the algorithm. So you can see here the initial situation is you have a stack of disks on a rod. They are of different size. The largest at the bottom and the smallest on the top. And now you have to move these disks from this rod to this one here without placing a larger disk on a smaller one. And you can move only one disk at a time. That are the basic rules. Sounds very easy, but it is a lot of work for a player or for the robot. And if you go to large numbers of disks, it will use really a long time to solve. According to the legend, by the way, monks were supposed to do this puzzle with 50 disks. And it was said that when they are finished, the end of the world would have come. Okay. Now, the script, it's in the editor. Here it is. Here's description and what to do. Project loaded. Then run the script. And after this you can change the number of disks. There's a variable right in the main program. Here it is. It's set to 3 disks. We can change this variable to 4 and run the script. And now we have 4 disks, and we can start the simulation. Everything here is, of course, pre-calculated. The script creates a path named Towers with 90 targets, and all the moves are here, printed by the script. 15 moves, status of the tower before the towers, before the move and after the move. So I can follow the procedure here manually. The algorithm is really a small one. It's a call to this function, stack disks. The parameters are the total number of disks and where to move. Okay, here it is, stack disks. It's only basically 3 little instructions. This function calls itself stack disks, decrements the number of disks. That's the number of disks on tower number 1. Then depending on the number of disks, we come back and we then start executing our first move and call the function again. It's very interesting to follow this with a debugger or watch the moves. Okay. The other functions of the script are we have a basic data structure for disks. Each disk has a number and a pointer to the cut model of the disks, and we have a stack of disks as an array of this record, and then we have a data type that covers each tower, the tower, T-tower. It has a base frame ID, the number of disks on the stack, and the stack itself. Each time you start the script will create a new path named Towers. If this path exists, it will be deleted. Okay, where is our algorithm? Okay, the core part here is for us the function move disks, where we execute the move of the disks of the disk from the from tower to the to tower. It's sometimes difficult to spell. Okay, here we are. Move disks from tower to tower, very basic. We create a description for our log entry. If you go with a number of disks higher than 8, you may comment this out, and this one here too, to save some time. Only a warning. Oh, by the way, if you choose to try this with 50 disks, you will really have to wait several million years. And if you don't want to wait this time, you can press escape to stop the running script. Okay, now let's change the number back to 3. Okay, now we have 3 disks. Start. And that's it. Can change to 6, for example. That will take a while. We have now 378 targets. Can increase the speed a little bit. Oop. Let's try 7. Here we go. I like it. Okay. You can download all this on our webpage. Search for demo version and have fun playing around with it. Goodbye.